The question is find the area and the lengths of the sector and the lengths of the arc lengths that are subtended by a central angle of 2 pi over 3 radians in a circle whose radius is 6 inches. So this question is basically to solve the area as well as the lengths of the arc of a sector. And in order to know what is the area and the length of the arc of our sector, we need to firstly know what is the sector in our trigonometric function problem. And in order to solve for it, they give some information through a circle. So we also need to think about the relationship between the sector and the circle. So in order to solve for this question, we have 3 things that we need to know in order to approach this question. And the first thing will be formula of area arc lengths of our sector. And your sector will be the main thing in our trigonometric function problems. Now we need to think about what is the sector in our trigonometric function values. And if you know from our equation, from the information, this will obviously going to have some relationship between this circle. So the sector can be either the part of the circle or the thing that generates the whole circle. So if you think about the definition of our sector, the definition of our sector will be a sector. A sector is an area, or you can say it is a part. So it is an area that is enclosed, which means it will be closed by something, and the something will be by 2 radii. By 2 radii. By 2 radii and an arc of our circle. And the arc of our circle. So there are 3 things that we need to know between our circle and the sector in order to think about the definition. And the first thing that we need to talk about is, for this sector, as we can see through our equation, it has some special information or the special relationship between our circle. And for that circle, it is an area, the sector is an area enclosed by 2 radii. And if you don't know what the radii is, it is a plural form, which means there is more than 1. So there can be either 2, 3, or 4 like that. And there are totally 2 radii, which means it has 2 radius. So by 2 radius and the arc of our circle. And what is the arc? They are the outline of our circle. So our arc value will be the outline of our circle. So before we think about it, we need to think about what is the radius too. So we need to think about the arc value as well as the radius values through our circle and get the definition of the exact sector through our part of our circle. So if you draw a full circle using the geometry dash, this is our circle, and the most important thing in our circle will be its central point, because the central point will be defined by a location of our circle. And from the definition of our sector, it is enclosed by 2 radius. And if you don't know what the radius is, so we can reduce the size of our letters in order to see clearly what the radius is. So the first thing will be, what is the radius? The radius, the definition of our radius will be the half of our diameter. And if you don't know what the diameter is, diameter means it is a straight full line in our circle. So diameter is a straight full line in our circle, which means we can think about the definition of our radius through our full length. And the full length should always go through our central point. And if you have a diameter, we'll just call this length as D. as its front letter of our diameter, and the half of our diameter will be the radius, which is we're going to be right over here. So this will be our radius, which I will notate it as the R value. And the definition of our sector is it is enclosed by our two radius, which means we need to have one more radius. So we'll just draw something like this. But remember that the radius should always pass through our end points of our outline in our circle as well as the central point. So this is what the two radius will going to be, but it is closed by the arc length, and the arc length will be the outline of our circle. So this will be an outline of our circle that I'm pointing out with our white marks. So this mark will be the arc length of our circle. So this will be the arc length of our circle, and as we can see, two radius plus an arc length, it will gonna form us a sector. So this will form us a sector, and this sector area will be the area enclosed by our two radius right over here and an arc length. And from here, we need to think about one more thing, that is always the most important thing in our sector will be an angle. So we'll just notate this as the data. The reason why the most important thing in our sector is the angle is because we know that in the trigonometric function values, and the sector is one of the trigonometric functions, in the trigonometric function values, the most important thing in our trigonometric function, already triangle trigonometry will be a location of our angles. So the most important thing will be the locations of our angle. And we usually notate as the data or the x degrees. And the reason is because the trigonometric function is the thing that will be defined by the angle. So the main angle will define the trigonometric values. So that's why the arc length of our circle's most important thing is our data, which we'll call it as the angle. So we can notate this in this way. The data will be an angle. In our sector. And if you draw information through our data, and the main area of our circle, we know that the main area will be the circumference. Where's the circumference? The circumference is the whole outline of our circle, and this will be 2 times pi times r. And the reason it's 2 pi times r is because if you measure exactly through our supercomputer, it will be 2 times pi, it will be 2 times r. What is 2 times r? The r shows that it is the radius. And what is 2 times radius? It will be a diameter. This means the whole diameter, if we do 3, the pi is almost 3.14. And if you multiply 3.14 to our diameter, it will going to give us the value of our whole circumference, which is the outline of our whole circle. So 2 times r will give us the diameter of our circle. And for the circumference, it is also a part of our arc length. They are the exact same definition. And it is a 2 times r, which is a diameter. So we will notate some more things that we'll notate. The second one will be our L. We'll notate our L as the arc of our sector. And the arc value in our sector right over here will be the thing that I'm coloring in with our violet color. And another thing will be, what is the point O in this case? Well, the point O, we can think about it is in a lot of videos that point O means it is the origin, which will going to be our central angle in our circle. So using these things, we might think about what is the sectors lengths of our arc and the areas. So the second thing we might think about will be the area as well as the lengths of our arc, which means it is a basic formula of our sector that forms it, which will going to be the formula for them. So the formula for our area lengths of our arcs. And we might prove it through our relationship, which we're going to be our circle. The circle has a specific relationship with our sector. So we'll compare the difference between the circle and the sector's formula of their arc lengths as well as the area of it. Firstly, we know that the area of our circle in our trigonometric function value will be pi r squared. And if you don't know what the pi is a irrational number, which means it never ends. The pi value will be approximately going to be 3.14. That is usually used by solving for a circumference as well as solving for the area of our circle. So we know that the area of our circle is pi r squared. We can see the area of our circle has a specific proportions with our sector. So the formula of our sector will going to be like something like this. So we know that our area for our circle will be pi r squared, and the actual area will be pi r squared data, and all of them divided by 2 pi. This is what the area for our sector will going to be. And if you don't know what this formula means, that means pi r squared times data divided by 2 pi means we're multiplying a specific proportions of our sector from the circle. And how do we notate it? From our data, which means the data will be a specific angle. So from our circle, and we will notate it by this specific angle. So our angle will be, what is the main angle? The angle will be a central angle of our sector. This is what the area between the differences between the area of our circle and the area of our sector is. Now let's think about the formula. The formula between the arc lengths, which means the outline of our circle, as well as the sector. And they also have a specific proportions between them, since we knew that the sector has a value that is part of our circle. We know that we're gonna call the L value as the H values of our arc lengths of our H geometry, which will going to be circle and the sector. And for the L, which will going to be the circles arc lengths, we know it will going to be 2 pi r. And what does 2 pi r means? It is a circumference. 2 pi r is a formula for a circumference of our circle, which means it is a full outline of our circle that shows the whole one. And we know 2 pi r is our circumference of our circle. But the most important thing that is the relationship between the sector and the circle will be the specific proportions. The proportions of our angle. The reason is because we know that the most important thing in our trigonometric function value is our angle. So the angle also in the sector and the circle, they have the specific proportions between them. So we know that the 2 pi r will be the circumference of our circle, and what is the L for our sector? it will be 2 pi r times x degrees divided by 360 degrees. So if you don't know what this h values means, we know that there is a L value, which means it is a formula for our arc length. 2 pi r, what is 2 pi r? 2 pi r will be the circumference of our circle. And then all of that times x degrees over 300 degrees or 360 degrees. It shows a specific relationship, the proportions between them. The reason is because we know that 360 degrees is a angle, main angle of our circle, and we know that x degrees will be the angle in our sector. So the angle in our sector over the angle of the circle, which means the proportions of our angle in our sector comparing to the angle of our circle. So this is what it means by the angles of each geometries. So radian is a new way or the method to simplify or convert our degrees into a specific format. And we've talked about this in the intro of our radians in the last time. And let's say if our degrees was something that goes like this, according to our 60 degrees format, we're converting our angle to our real numbers, not a degrees. So the radian is basically converting our angles to our real numbers, not a degrees. So there was a specific or a special equation for it, or a formula, and we know that 360 degrees will be a 2 pi radians. That means what is 180 degrees in radians? Well, it is half of our 360 degrees, so it will also be half of our 2 pi radians, which will going to be our pi radians. So this was a thing that we had to know in order to solve for our equation, and this was also explained the relationship between the sector and a circle. The sector has a special relationship with our circle because it was originated from our circle values. In our equation, it says there is a sector, which is part of our circle, and the sector has a obviously going to have the arc length as well as our area. But they didn't give us the exact values of our arc length and the area because they are things that we need to solve. But the information that they gave us will be the central angle of our circle. What is the central angle of our circle in this case? It will be 2 pi over 3. So they made our central angle, which should be in degree mode, into our radians mode, since we knew that there is a pi, which means they convert our angle into a real number formations. So we might be able to convert our radian mode into degree mode. Now it won't be a matter of solving this question, but we can do it as a practice of converting our radian mode into our degree mode. Well, we know that 2 pi is 360 degrees, and all of them, so in this case 2 pi divided by 3, which will going to be 360 degrees divided by 3, and our central angle will be 120 degrees. But it won't be really useful when it comes to solving this question because we know that this is a question of our radian mode. So we need to solve for it according to what question told us. So the central angle of our circle is our 2 pi over 3, and our radius. And what is our radius? It is a half of our diameter. what is the diameter? It is a full length in our circle. And the half of our diameter, which is our radius, will going to be 6 inches. So we have our two informations that will be useful when it comes to solving this kind of sector problem. And this is just the basic questions. And the most easiest way to solve this question will be to convert our information through our actual geometry stuff. So they are totally two informations that are given, and they're all according to our circle. So we might be able to draw a circle value and notate every single values or information that they gave us through our question. So here's our circle, and the most important thing will be our central angle, and I will notate our central angle as O. And it will be x comma y if it is on the coordinate plane. So our radius will be like something like this, that it should always pass through our endpoint of our circle and a central point, and that will gonna give us our radius. And this one radius will be our 6 inches. I will just abbreviate our inches, and I will just write it as the 6 because they told us that the radius of our circle is our 6 inches. So this will be our values. And another thing that they gave us is what is the central angle. And the central angle will be 2 pi over 3. And we know that 2 pi over 3 in our degree mode is our 120 degrees. So it will be 120 degrees, which will look something like this. It will be more than 90 degrees. And this angle will be 120 degrees. Or we can just write it in our radian mode. 2 pi divided by 3. So this will be our main angle that defines our sector values, and this will be obviously going to be the arc value. And here's our first question. So for this arc value that enclose our sector, this will be arc length. So let's remind ourselves what is the formula for solving for our arc length. The arc length, the arc formula. The formula for our arc value will going to be 2 pi r times x degree over 300 degrees. So 2 pi r times x degrees over 300 degree or 360 degrees. And we know that in this case, the r value will be our radius, and our x degrees will be our central angle. It will be a central angle of our sector. So what is our radius? Our radius value will be our 6, so we will replace our r value as 6. So it'll be 2 pi times 6 times our x degrees. What is our x degrees? 2 pi over 3. So 2 pi over 3. All of them divided by 360 degrees. And if we simplify this form, or we can say it's an equation, we'll be able to solve for our arc length. The most important or the easiest way to simplify this is make this into a fraction, not to be confused when it comes to making a calculation for it. So it will be 2 pi times 6, which will going to be 12 pi. All of them times 2 pi over 3. Divide by 360 degrees. So if we simplify this, we'll be able to get our arc length. And if we simplify it, we're going to get what is our 360 degrees. Well, our 360 degrees in our radian form is our 2 pi. The reason why we convert this into a 2 pi, which is our radian mode, is because we know that this is all formed by a radian, but if there's just degree, it will be complicated calculation. So 2 pi and 2 pi, 2 pi and the 2 pi, we're going to cancel out, and we'll get 12 pi divided by 3. What is 12 pi divided by 3? Well, it will be a 4 pi. And it will be a 4 pi inches. So our 4 pi inches will be what the arc length will going to be. So 40 pi inches will be our arc length. So which means our arc length that form or enclose our sector from our circle, this length will be 40 pi inches. And we have one more thing to solve, which is our area. Our area, whole area of our sector. What is the formula for our area of our sector? The formula for our area will be 1/2 times r squared data. So 1/2 times r squared data. And what is our r in data? R will be our radius. And our data will be our central angle of our sector. So apply our formula. We'll write this in our spaces right over here from our spaces. And 1/2 times, instead of r, we apply our 6 inches times square, which is multiplying itself together one more time. And all of them times data, which is 2 pi divided by 3. So let's simplify this. What is 6 squared? Well, 6 times 6 is 36 times 1/2 times 2 pi over 3. 36 times 1/2, well, we're going to be 18. And it times 2 pi over 3. 3 and 18 will be cancelled out as 6. 6 times 2 pi will going to give us 12 pi. So 12 pi will be what the answer of our area will going to be. So our area will be 12 pi. And this question was basically about a basic question for our sector and converting our radians to our degrees, special relationship, which will going to be the first step when you learn our trigonometric function values.